Good afternoon, all of you. Happy Independence Day. And let's tackle this beautiful problem. The beauty of the problem lies in this statement because nowadays you must have seen the JEE problem is more about putting spices in the problem, and the art lies not only in asking the concepts but also in designing the language of the problem. That's very crucial because once you have failed to understand the meaning of the problem just drops there only. Okay, so let's try this one. Let S be a set A comma B such that A is from 0 to 1 and B is from 0 to 1. So understanding the meaning is very crucial and is as crucial as applying the concepts. A unit S square in R2. So set S represents unit S square. You must have witnessed in the last 2-3 years vectors and 3D problem was also given in this set notation where they have used a set notation to describe a unit cube as well. There can be many ways of describing unit S square and unit cube. For example, one of the way can be even mod x minus y plus mod x plus y plus 1 equals 1. Is basically you can take this kaju wala barfi and you can rotate this by 45 degree, and then by proper scaling you can also write the equation of a square just in a single format, like in a single capsule. Anyway, so that was an extra point as an Independence Day special. Let B be a set x comma y so that x square plus y square is less than equal to 1. Clearly that's a unit disk because of inequality in R2. R2 means, remember, it's R cross R. R cross R means it's a set of all x comma y such that x belongs to real world and y belongs to real world. So basically R cross R is the entire coordinate plane. Okay, 2D plane. Now we define a set S plus B as follows. S plus B is all u comma b such that there exist a comma b belonging to S and x comma y belonging to b such that u equal to sum of x coordinate and b equals sum of y coordinate. Then what is the area of S plus B? So it's a very simple but elegant question from area bounded figure. Of course, the same problem can be kept in the language of complex numbers. It can also be shrouded in the language of vectors algebra. Okay, so I would like some of you create the nice wording and try to put in the comments box in vector language or complex numbers language so that I can incorporate that even in my coming textbook. Anyway, so let's just start and see how you can solve this problem. So since we have noticed set S is a unit S square, so let me draw square over here. And since it contains all the point within or on the boundary of this square, so it will look something like this. That is representation of set S. Representation of set B is equally good. So we have set B is a unit circle. Now all the points inside the unit circle or unit disk will be set B's, and you can see we have a region which is overlapping. So this is the overlapping zone between both of them, right? So this zone is overlapping between both of them. Anyway, so now we need to take any point x over here from the square. Let us call that point I'm calling at S, and I can take any random point B from the unit disk, and we need to add this. So the addition is very obvious because we can add this vectorically. The reason being the x coordinate of S, let's say it is a comma b within a square, and for the circle let's call that point to be x comma y. So if I'll add, the u coordinate will be addition of x coordinate a plus x and y coordinate will be y plus b. That's nothing but by law of parallelogram it will be the sum total of these two lengths. So if I add these two lengths using parallelogram, I'll get this new point u comma b over here. Now as all these points S and x comma y spans through the entire region of a square and circles, we need to create the locus of all u comma b. So what I'm going to do here is first I'll solve this in a pure geometrical style, and then you can capture this information by algebraic equation as well. Okay, so let me draw again square, and we have a nice circle over here. Let's consider the extreme points for timing, because that will help us to clearly see the boundary of where exactly it's going. So we have these two regions, and first I'm interested between the extreme point of this region. So let's say I number this as 1, 0, vertices of square is 1, 1, 0, 1, minus 1, 0. So these are the useful points, a critical point for our analysis. 0, minus. So remember, I'm not using critical point with respect to calculus here. These are the special points which gives us a rough feel of how the graph will look like. Of course, we have 0, 0 over here. So now we can clearly see, if I take a point 1, 0, which is a part of a square, and 1, 0 again a part of a circle, so that will send me to a new point 2, 0. So we'll have one point over here. Again, if I take 1, 1 and 1, 0, so that will give me 2, 1. So I'll have point over here 2, 1. So now we have region, so we'll get one point over here 1, 2, 0. So now I've got an additional region. Now the claim is, can I get any point on this region by their combination? The answer is big yes. So I can explain you over here. Suppose we have a random point P. So this point will have this additional x coordinate over 1 and some additional y coordinate. Now corresponding to the y coordinate, I can always do reverse engineering. So I can always move back, right? And the same height, if I take any point over this line y equal to, let's say that point coordinate is h comma k, where h is 1 extra. So let me call it 1 plus h comma k. So I can clearly create a height of k as long as anywhere I am on this line, right? So we have 1, 0 and plus what point addition will give me. So let's say this distance is h. So I can have a point h, 0 over k over here. So h, k is a part of circle, right? And 1, 0 is a part of square. So I have got one point over here, 1 point over. Now if I'll add the x coordinate of this one, clearly 1 plus h is going to come here. That is 1, 1 plus h, and the height is same. So yes, I can create any point. So given any point on this black region, there is a bijection. So I can always find a point corresponding to a circle as well as a square, which will map to the black region. So all these points is achievable, right? So that gives us the existence of all these points over here. Now by symmetricity of the argument, I can clearly see if 1, 1 exists and 0, 1 exists. So clearly I can add, so that will give 1, 2. So straight back here 1, 2. In the similar fashion, 0, 1 and 0, 1 will give 0, 2. So I'll have another black region over here. And that can be argued using symmetricity as well, right? Now, are there points in this region? The answer again is affirmative, because let's say if I consider this diagonal, so its distance is going to be √2. If I take 1, 1 and add exactly this point 1 by √2 plus 1 by √2. So let's say this point is P0. This P0 coordinate is 1 over √2, 1 over √2. You guys make 45 degree. And that point is on a circle. So if I'll add this distance, this square plus this extra portion will simply be pushed out over here. And again, so if we'll add this OP distance with this diagonal distance, I'm going to exactly land over here. So, and again, it can be shown like if I take any point on this periphery, that will be nothing but addition of all these points over here to the corresponding point 1, 1. Or if I can add these points on this boundary, so still I'm able to achieve this region as well, right? Now let's come to the other quadrant and see whether it is achievable or not. Again, in the similar manner, minus 1, 0 is a part of the circle. What if I add 0, 1? So basically I'm adding these two vectors. You can imagine it's some j cap and minus a cap, and I'll create all the points in this region. Okay, so this entire region is again the part of our new set UB. What about a further point over here? Again, there is no wonder. Like if I consider a point, let's say minus 1 comma 0, so I can pick up any height over here. The reason being, now we are not allowed to take point from here because a square is there, right? So what we can do is, what if I take a point within the square? What if I take point within the square and a point in this negative half, like in the second quadrant of the circle? If I add the coordinate is always be a fraction. And if we'll add the height, so that will grow up. Right? So for instance, suppose if I consider a random coordinate. So let's say if I consider a random coordinate over here, some point P. And if I consider some point Q in this square region. So now we need to add these two vectors. And if the orientation of vectors, because the vectors makes more angle towards the second quadrant, so clearly these two vectors will go and it will come somewhere over here. So that shows in the extreme case, we'll get again this quadrant of the circle. The reason why we are not getting this point is, to get the coordinate of this point, our coordinate should be, let's say this corner if I talk about, so it should be minus 1 comma 2. That can never be achieved because minus 1 comma 0 plus the only way to be at minus 1 is to create 0 comma 0, like x coordinate 0, right? And to create 2 we need y coordinate 0, so that's not possible. That's why we'll get again a quarter part here in the second quadrant. Agreed? What about the other reason? So let's come back over here. We have minus 1 comma 0 and 0 comma 1. So if I'm going to add this, that's not possible because minus 1 comma 0 is gonna give me x coordinate minus 1 and y coordinate 0. If I add the point, let's say any point 1 comma 1 over here, so I'll get 0 comma 1, which will send here, because all these vectors when we'll add it, this will go up, so it can't come down because you have no component which is able to pull it down, right? Similarly, is there any way like we can get the point, let's say 1 comma minus 1? Yes, that's possible because we have 0 comma minus 1 over here, it's a part of the circle, and 1 comma 0 over here, so that will add to give 1 comma minus 1, hence even this portion can be got. Okay, so we can get that portion. Now one last thing, by symmetricity, again if I consider any point over here, and let's say any point in the square, so their summation still it will go beyond this region and that will fill up the quarter over here. So I hope you have enjoyed the problem and you see how beautifully this locus will look like. Okay, so finally we are done with the question. So we have 1 square over here, 2 square, 3 square, 4 square and 5 square, as you can see, and one complete circle. So we have 5 square. In the name of circle we have 1/4 plus 1/4 circle plus 1/4 plus 1/4. So these are the part of circles for your clarity, and we have 1 2 3 4 and 5 square. So and the answer for the problem is 5 times area of 1 square is 1 plus a full circle which is having area of pi. And answer for this beautiful problem goes to 5 plus pi. If you have enjoyed the video, please do like and subscribe because it takes time to even come with these exciting problems, which is based on very fundamental logic of your JEE syllabus and is useful for most of the competitive examination at 12th college or undergraduate level in India. Thank you. Have a good day.